So, welcome you all for another presentation on the concept of random variables. In today's presentation also, we will see some important parameter of random variable. Okay, concept of random variables. So, with respect to this topic, in our previous presentation, we have seen one important parameter of any given random variable x, right? We have considered any random variable x. For this random variable, we have seen the expected value. Clear? We have seen the expected value of random variable x as that is denoted as expected of x. This we have seen very clearly. So, this expected of x is nothing but expected value, or also called as mean value, or otherwise also called as average value, right? And we have seen that expected of x, if x is a continuous random variable, then expected of x is given by with this formula integral over minus infinity to plus infinity small x into f of x into dx. This we have seen. It is the formula for a continuous random variable. Whereas it is, if it is a discrete one, then normally so summation will come. Sigma, this symbol is called as sigma. It is x suffix I into p of xi. So this we have seen, where I is equal to some 1 to n you can take. Okay, this is also expected of x, right? This is for continuous random variable, whereas the second formula, the second one is for discrete random variable. So these are the formulas that one should remember, right? One should remember. These are the very, very important formulas. This we have seen, and one of the example also we have seen in our previous presentation. In today's presentation, just I would like to explain you about the second important parameter of any given random variable. Normally we are considering capital X. We are considering random variable X. With respect to X, we are defining certain parameters, out of which we have seen the first one, that is expected value of X. And this, in this particular presentation, I would like to explain about the second parameter, that is variance. What is that? Variance. That is denoted by sigma square. Variance is the another very, very important parameter of a random variable x. Variance, that is denoted by sigma square, right? So sigma square is mathematically given as, sigma square is nothing but expected of, there is a formula for this, it is the expected of random variable x minus its mean value, means e of x. Take the whole square in between. If you consider this, that is the formula for the variance. Understood? So this is the formula for the variance of a random variable sigma square x. You can write like this: sigma, this is called sigma square suffix capital X, means it is the variance of random variable x. So variance is denoted by sigma square. If you consider the random variable x, then it can be written as sigma suffix x. If it is random variable y, then you will write here y in place of x, write the capital Y, or z capital Z, that is. So it is the expected value of, means that what, if you observe in the bracket, you are taking the difference between, this is what you know, clearly observe here. So this is the difference between, it is the difference between random variable x and its mean value. What is the mean value of x? E of x. E of x, is it not? X is the random variable and its mean value is E of x. If you take the difference between these two, what is the difference? x minus e of x is the difference. That is what here I have written now. X minus e of x is the difference. X minus e of x is the difference. So for this difference, if you take the square, then take the square, afterwards expand with respect to that a minus b whole square form, then whatever comes after expanding, then you take the expectation to that expanded one. Clear? So I will expand this particular expression for your understanding, right? I hope you all are getting. Nothing too difficult, nothing to confuse, nothing to feel confused. So it is the variance sigma square of x is equal to, it is the expected value of the random variable x and its mean value e of x. Clear? Then put a bracket. This is the difference. For this, take the square. That's it. That's it. That is the definition. Getting? So random variable x minus its mean value, nothing but e of x, then take the square. So now expand this with respect to, so you can write e as it is, right? So this is, consider x as a, this as b. Now a minus b whole square form. What is a minus b whole square? It is a square plus b square minus 2ab, is it not? Therefore, if you expand like that, it is nothing but x square, is it not? A square plus b square. B square means what is okay. So here for your convenient, you just remember one thing, that expected of x can also be written as mu. Remember that expected of x can also be written as mu. Okay, that is the mean value actually. Therefore, you can write in place of e of x as mu also. Therefore, if I write e of x as mu, then definitely nothing but mu square, no? Is it not? A square plus b square minus 2ab. 2 into ab. What is a? X. What is b? E of x, that is mu. So expansion is over. Is it not? So a minus b. So e expected of x is nothing but mu. So mathematically expected of x can be denoted as mu. Therefore, if you write mu here, therefore a minus b whole square form, that is a square plus b square minus 2ab. A square x square plus b square, nothing but mu square minus 2ab, 2 times x into mu. Is it not? Now expansion is over. Now you apply this expectation to these things. Whatever the quantities are there in the bracket, for these quantities you apply the expectation. So what actually, this is nothing but expected of x square. You can write like this, expected of x square plus this is expected of mu square. Is it not? Expected of mu square. So you simply write expected of x square. Okay, then plus, right, expected of mu square, right, like this, expected of mu square minus expected of 2 times x into mu. Clear? You are getting or not? So what is the next step? This is equal to, the next step I will write here, the further step. It is very simple, nothing to feel any difficult here. It's very simple mathematical expansion only. So what is the next step? So it is sigma square of x is equal to, expected of x square is expected of x square only. There is, then it is expected of mu square. Remember that. Remember one thing. Mu is a constant. Expected of x is nothing but the mu. Mu is a constant, means that the mu value is a constant. Therefore, if you take the expectation for a constant, the value is a constant only. Therefore, expected of constant is nothing but constant. Therefore, expected of mu square is nothing but mu square only. Understood? Mu square only. Now, in this expression, Let us see here expected of 2xy. So here, as I already discussed now, mu is a constant because mu, what is mu actually? Expected of x. So expected of x is nothing but mu itself is a constant. Therefore 2 is also constant. Therefore you can write 2 mu as outside. Means that what, minus symbol is there. I am writing minus here. So 2 mu you can take outside. 2 into mu you can take outside. Then take the expectation for random variable x alone, because the expectation will be taken for random variable only. Understood? The expectation will be taken for the random variable only. It could be either x or y or z or whatever it is. Therefore, the expectation will be applicable for the random variable. So, except that random variable, whatever the other parameter is there, we have to consider them as a constant. Therefore, 2 into mu, 2 mu will be considered here as a constant. Therefore, 2 mu you can write outside like this. Then it will be 2 into mu e of x. Therefore, again, what is e of x? It is mu only. Therefore, if you expand further, it is expected of x square plus mu square minus 2 into mu. Is it not? 2 into mu. What is expected of x? It is nothing but mu, no? Expected of x is nothing but mu only, because expected of x can be written as mu. Therefore, this is equal to expected of x square plus it is mu square minus 2 into mu means mu square. Therefore, 2 times mu square. Therefore, finally, it is expected of x square mu square minus 2 mu square. How much? It is minus mu square. Minus mu square. That is what sigma square of x. This is the formula that you have to remember.